Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nur Zakwan bin Muhammad Asri. My friends and I will present about our group project MAT523, which is relationship between body weight and fat percentage. This is our members, Zakwan, Yusrizal, Amma and Wan Hazi. The overview of this presentation, which is introduction, implementation of each models, graph of each models, and analysis and conclusions. First of all, the introduction, body weight and fat percentage in relation to one another. Therefore, as when human eat many junk food will make their weight increasing, so the fat percentage changes, and this means the fat percentage is independent variable and body weight is independent variable. We are using 4 mathematical models to find the best fit curve of this data, which are linear model, quadratic model, cubic model, and the last one is quartic model. Based on table 1, this is the real data that we obtained from body weight and fat percentage. We took 20 data points from the real details to comparing the variable x and y. The x is body weight while y is the fat percentage. The first model is the linear model. The equation is y equal to a plus bx. The blue one is the data that we obtained. The normal equation we can obtain from a transpose multiplied by a and a transpose multiplied by y. The least square solution we can obtain from a transpose a inverse multiplied by a transpose multiplied by y. Therefore, from the least square solution, we can obtain the best linear curve, which is y equal to 0.1716 plus 0.0009421x. Next is the error vector. Error vector we can find from y minus ax. Then we can find the magnitude of error. The last one from the linear model, which is the graph. The first graph is the graph of best fit curve against its observed data. Then the second graph is graph of the error vector against the x values.
Hi, my name is Muhammad Ahmad Ifan bin Azhar, and I'm here today to represent the quadratic model. The next model is quadratic model, represented by as y equals to a plus bx plus cx square. The blue number on the right, as you can see, is the data for the quadratic model for x and y. From the data, we can get the normal equation using formula. Next, we also can get the least square solution by using formula A transpose times A in bracket inverse times A transpose Y. Then, the best fit quadratic curve is Y equals to negative 28.74 plus 0.8716x minus 0.006553x squared. Next, we find the error vector using the equation y minus ax. So, the magnitude of error that we get from the calculation that we had done earlier is 7.72944 and so on. The last segment for this presentation of quadratic model is the quadratic model graph. The left graph represents the graph of the best fit curve against its observed data. The right graph represents the graph of the error vector against value x. So, as you can see, both are the graph that we made earlier. So that's all from me. We continue on the next model.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Yusuf Hakimi bin Muhammad Yusuf. Let's proceed with cubic model. Definition of cubic model is mathematical model that represented by x model equation such as y equal to a plus bx plus cx squared plus dx cubed. Next, we set up the matrix based on previous data, become M matrix from data x value and Y matrix from data Y value. From the least square solution that we get, we can find the best fit curve is Y equal to negative 27.97 plus 0.504x minus 0.0064498x square plus 5.828 times 10 power of negative 7 x cubed. Then we find the error vector using formula E equal to y minus ax. So from the value that we get, we can find the value of magnitude error, which is 0.0053530274782707169. There are two graphs here, which are graph of best fit curve and graph of the error vector.
My name is Wan Muhammad Zimupi, and now it is my turn to present about quadratic model. As you can see, this is the examples for quadratic model, which is equation y equal to a plus ps plus cs power of 2 plus ds power of 3 plus es power of 4. For example, if I enter 165.6 4303.36 282,300.416 and 1.851890729 times 10 power of 7 for quadratic model, I will get y, which is 0.234. Now, these are the normal equation for quadratic equation. We already know that a times 2x equals to y in matrix equation. Therefore, top left we consider as a, while x represents a, b, c, d, and e. The least square solution is x. So if we combine together, we will get the right side as x. Hence, the best fit square quadratic curve is y equal to 874.04 minus 35.378x plus 0.402x 27x power of 2 plus 6.7057 times 10 power of minus 7 x power of 3 minus 0.00001547 x power of 4. This is the error factor for quadratic model. For error equation, E equal to y minus ax. Y represent on the left side, while the other one represent as. For example, if 0.234 minus to 0.23186244598031118, we will get answer for E, which is error. Hence, the magnitude of error for quadratic model is 0.006106 79585139109576. Here are two graphs. As we can see, the graph on the left is a graph of best fit curve against its observed data. Here we see that a slightly horizontal lines starting from point 6.3 to 6.7. As we can assume that the values are almost same. Meanwhile, on the right side, the graph shows the error vector against x value. Okay, now the table shows the analysis for the equations and the value of error. The analysis shows that cubic model has least error magnitude while linear model is the most. In conclusion, the best fit curve in this case, which will give the best approximation, is cubic best fit curve because it has the minimal error in terms of its magnitude, which is 0.005353027547827071169. That's all for my presentation.